we are with a very interesting problem type. As you can see, the question, it's a very short question, and this question was given by one of the great mathematician of all time, G.H. Hardy. So, before proceeding for this problem, we try to give you a small introduction on our problem type series. What we are going to do in this problem type series is that we are going to solve those problems which are repeatedly asked or can be asked, or those problems which give a conceptual boost. You can the miscellaneous problems or the high level problem that we are solving, that gives a boost to your problem solving skills, in which we are mixing coordinate geometry with the concepts of uh, sequence and series that we have seen in this problem, the last problem in this problem. So, but what we are doing here in this problem type series, that will give you conceptual boost, and that will give you boost in your problem solving skills. Both will maintain a balance is very much important. So without wasting much time, let's try to solve this problem. See, this is a very easy problem if you can crack. In every problem we try to give the motivation of the problem. That's how we get motivated to solve this problem, and here this part is the motivation indeed. I would say that this is so basic thing, but it's difficult to crack at the pressure, and lot of us won't be able to crack it. But this we all have studied whatever you are studying. Even if you're studying for boards, we all have studied that, because it's there in NCERT. In integration, we all have seen integration e to the power x, integration e to the power x, fx plus f dash x. We all have seen this. Even this is so basic that this there's in NCERT book. But to crack this in limits, to correlate concepts in such a way, this is what makes this problem beautiful. So what's the funda of this problem? The funda is very simple and clear. See, if we write e to the power x, fx as a function, say hx, this is the motivation of the problem. This is the motivation of the problem. And if we differentiate hx, h dash x, we'll get, using UV rule of differentiation. If you know UV rule of differentiation, that's u v dash plus v u dash. We can write it as e to the power x f dash x plus, differentiating e to the power x now, e to the power x fx is now as it was. Now I can take e to the power x common. What we will get? F of x plus f dash x. So this is the important thing. Now how we will apply this in limits? How we will apply this in limits? Let's see. This is the motivation. This is the motivation. Every problem we are giving you the motivation, because maybe they will ask this question in some another way, in some in let's say integration or in differential equation or in limits. They can ask this question anywhere. Means using this concept or this motivation. So that's why motivation is the most important part of any problem that we are solving. Even when you are solving the JEE advanced previous year question, it's suggested that you should find out the motivation of the problem. That's very important. Now let's try to find out the limit. Limit x tends to infinity f of x. So we can easily see that limit, what's happening, wait a minute, Yes. Limit x tends to infinity. E to the power x f of x whole divided by e to the power x. We can write in this way, multiplying numerator and denominator by e to the power x. Now, one thing that should be given in the question, that fx is finite. Fx is some finite value. This is some finite. Okay, some finite value. Fx is some, say, b, where b is some finite value. We need to find b. Okay, that's the question. More appropriate that would be. Otherwise, you will say that that's not defined or infinite. You will say. So we can see that here e to the power x x tends to infinity. It's infinity by infinity form. So we'll use the L'Hopital rule. L'Hopital rule and differentiate both the numerator and denominator. We'll get e to the power x fx plus f dash x. What's happening? Whole divided by e to the power x. X tends to infinity. This will get cancelled, and the value of this limit we will get as this value is given. This value is given as a. We'll get this same as a. And this is why this question is a very interesting question, because you can see that this is a very short solution. This question can be solved alternatively using Cauchy's mean value theorem, but we are going to solve this using L'Hopital rule. This is going to be very easy part. What is important is this motivation of this problem. Now let's try to solve a very similar question using these concepts. That's some given value, and we need to find limit x tends to infinity f of x. So how we will proceed? See, here we can see that extra 3 is coming. How will this extra 3 come? From where will this extra 3 come? See, e to the power 3x f of x. If we differentiate this, what we will get? E to the power 3x f dash x plus 3 times e to the power 3x f of x. This will give us e to the power 3x f dash. I'm not writing again and again that 3 plus f. That's what given in the question. That's what we have in the question. So here, instead of e to the power x, we will consider e to the power 3x. So now let us solve this problem. Limit x. What's happening? Limit x tends to infinity. F of x is same as limit x tends to infinity. E to the power 3x f of x. Limit x tends to infinity. Now you'll use same L'Hopital rule or L'Hopital rule. Don't go for the pronunciation. We'll have e to the power 3x f dash x plus 3 times e to the power 3x f of x. Here we will have 3 times e to the power 3x. What is the question? Wait. Now let us cancel this e to the power 3x. This value we have been provided with, what's this value? F dash x 3 is 6. This value is 6. Okay, this value is 6. This value is 6. Limit x tends to infinity. 3 by 6. Answer is 2. So this was a little bit modified version of the previous problem, and again and again I'm repeating the same word, that don't go for the fact that this is an easy problem. Yes, this is obviously an easy problem, but if you cannot crack this f dash x plus fx and relate it with e to the power x fx, then you won't be able to solve this problem even after spending a lot of time, and that's what makes this problem very interesting one. So here the level of the calculation, you can say, or problem solving skill will not be that much, but the concepts we'll get in this pattern problem is going to be very much excellent. So that's the speciality of this new series, problem type series. Thank you.